For this laboratory activity, you will be needing the following. First, a large container with controlled water flow like this jug. Second, a smaller container with known volume like this 1-liter measuring cup. Third, a stopwatch. And lastly, water to simulate the water source. For this setup, the water is placed into the jug and we dye the water into pink for better visualization. To start, place the bigger jug higher than the measuring cup. Place the measuring cup right down the faucet. Open the faucet and at the same time start the timer. Allow the water level to reach the specified mark and document the time taken to reach it.
Moving on, there are a few things we need to solve and answer. First is to calculate the flow rate using the formula Q is equals to volume over time. Second is to estimate how much water source could provide in a day. And lastly, given that a typical household might use 300 liters of water per day, check if the water source is able to meet this demand. First, we need to solve for the flow rate. The given values are the volume of the measuring cup, which is 1 liter, and the time it took for the big container to fill up the measuring cup, which is 34.75 seconds. Substituting these values to the formula, we have 4 over 139 liters per second. Second that we are going to solve for is to estimate how much water source could provide in a day. So from the 4 over 139 liters per second, we're going to convert this into liters per day. To start, we need to convert seconds to hours, and we know that in 1 hour, there are 3,600 seconds, and for 1 day, there are 24 hours. So canceling the units, this left us with liters per day, and our flow rate now will be 2,486.331 liters per day. Last question is that, given that a typical household might use 300 liters of water per day, check if the water source is able to meet this demand. So our flow rate of the source is 2,486.331 liters per day, which is far more than the consumption, which is 300 liters. Therefore, our water source is able to meet this demand of a typical household.
Good day everyone, I am Manuel Guzman and I am here to answer the question, how does the flow rate affect the overall water source capacity? What factors could influence the flow rate? So the flow rate plays a crucial role in determining the overall capacity of a water source, as it directly affects the amount of water available over a given time frame. A higher flow rate means more water can be accessed within a set period, effectively increasing the source capacity. Conversely, a lower flow rate reduces the volume of water that can be collected, thereby decreasing the usable capacity. Several factors can influence flow rate, including the size and design of the container's opening, which impacts how smoothly water can pass through. For instance, a larger opening or a well-designed spout allows water to flow more freely, decreasing the flow rate. Additionally, water pressure often affected by gravity, such as the height of the container, can lead to a faster discharge and consequently a higher flow rate. These factors determine how reliably a water source can meet demand over time, especially in scenarios where consistent capacity is essential.
In analysis question 2, in real-life situations, the variable flow rates in water sources like springs or wells which can significantly impact their reliability, affecting both the availability as well as the quality of water. So for seasonal changes, such as in dry seasons or in drought, which can reduce the flow rates, limiting water supply for communities in the urban areas, in agricultural as well as in industries that rely on a consistent volume of water. So when it comes to overuse, often seen in growing population areas or here in Cagayan de Oro or other cities, which rely on a high water demand, which can also decrease the flow rates as the source is stopped beyond its natural recharge capacity. So lower flow rates may lead to issues like insufficient pressure, causing difficulty in accessing water and possibly affecting the water distribution systems. So additionally, reduced flow can concentrate contaminants, decreasing the water quality and posing health risk. So when it comes to rainy seasons or in wet seasons or the periods having a low demand, the flow rates may increase. But this alone doesn't ensure its reliability. Why? Because as excess water might not be effectively stored or managed for later use. Thus, maintaining reliable water source often requires balancing withdrawal rates as well as monitoring seasonal variations and implementing conservation strategy to ensure a consistent and safe access to water across changing conditions.
If a community's demand exceeds the water source capacity, what strategies could be employed to manage water use or increase the source capacity? There are plenty of strategies that could be employed to manage water use and increase water source capacity depending on the location, population, and classification of water source available in a specific community. In the case of water use management, decreasing the period of daily water extraction can be employed to avoid exceeding the capacity of water source. This strategy is applicable if the water source is groundwater or spring. Tariff design could also be a wise strategy to control water use in the case of level 3 house connections. Increasing the capacity of a single water source could be demanding as the recharge depends on the climate and geography of the community. However, we can increase water source capacity by considering other available water sources rather than relying on a single source only. An example of it is the dual water supply that involves rainwater harvesting and groundwater extraction. If the water demand still exceeds the source capacity, then it is desirable to upgrade to level 3 house connection as it relies on larger reservoir.